Hello and welcome to another video, and in this video we'll be looking at SmolAgents. SmolAgents is like a library or a framework which we can use to build agentic flows, or not workflows but simple scripts, or to call tools or generate code and basically have autonomous decision making behalf of the user. So SmolAgents is very lightweight and very easy to use framework library which is developed by Hugging Face, and it allows us to use local LLM models with the help of LiteLLM, which is a wrapper which helps us in executing all sorts of LLMs which are available exposed via an API. So let's get started. First we need to install this package which is called SmolAgents. I've already installed it, so I won't be doing it again. So you can set it up on your Python environment. Once that is done, we can get right into the code because it doesn't require any other dependencies. So first we need to import the package. We'll do from SmolAgents import tool calling agent. This is where the actual agent will be used for orchestrating other tasks. Then we need some tool, that is what type of processes we want to run by calling the agent. Then LiteLLM model, this is where we will be declaring or defining what the LLM to use for the decision making. Now we need to define a few tools. This is not necessary, but to get an example clear, we will be using tool decorator for any function that we want to write. So let's say the simplest example we can think of is multiplication and add. So I'll just create a function with multiply x and y, which we need type hinting and docstring to make this very verbose, and the LLM can understand what the function is, and given a prompt it can understand what to execute next. So we have given x and y as a integer parameters, and it should return the integer by multiplying these two numbers together. And in a docstring we'll provide the same thing, takes two integers and multiplies them together. So we need a bit more verbose things, so we'll add what each of the argument means. X is the first number, y is the second number, and returns the multiplication of the product of two numbers, and returns x times y. This is very simple and straightforward example, but you can see where this can help in making complex functions and running LLM on top of it. Then we can define one more tool, which add, simply by taking two parameters and adding them together to get in one more integer. So this will be the same thing that we did for multiplication, just it will be adding the numbers. Now this is where the actual LLM comes in. We need the LLM name, so we can say Olama / Llama 3.2 1 billion. Now I am using Olama, so if you see Olama pull, you can say Llama 3.2 1 billion. This is just one way of pulling out a model from the Olama registry into your local system. And after you have pulled this is a little on the higher side, it is around 1 or 2 gigabytes. If you run this, you can interact with the local LLM with this prompt, with this like interactive CLI app, or you can also use API, but to demonstrate you can see this will respond it in a sequential manner. So that is how you can use local LLM. I have a few local LLM models. You can see SmolAgents, which is very lightweight, Gamma 3 1 billion parameter, Llama 3.2 1 billion, and DeepSeek R1, which is a thinking model. We don't want to use it right now. So I've provided the model name, which is Olama. It understands that it is a local model, Llama 3.2 1 billion parameters, which I have already installed and is working on my local system. Then I need to initialize the LiteLLM model, which will take in this model ID as a model name. Now this is a wrapper around LiteLLM, which is another library, Python library or JavaScript library, which can interact with all sorts of LLM and provide you a singular interface for interacting with all sorts of LLM. So then we construct the agent, which will be calling tool calling agent. There are other types of agents like code agents and multi-step agents, but right now we want to make sure that we provided a prompt and execute a few tools on behalf of us, and let LLM take the decision based on what the prompt is. With that tool calling agent, we require a few parameters, as you can see, the tools and the model. The tools, we can provide a list of function names, which will be multiply and add that we just wrote. In the model, we just provide the LiteLLM model, or it could be any other model that you can use, OpenAI, Anthropic, Gemini, or any other model you want. We will see the example with Mistral in the later sections, but for now we will using a local LLM model with the help of LiteLLM. And the verbosity, these are just additional parameters that I'm tweaking to make sure what we see in the output. Add base tools just for convenient. There are some base tools that we'll be using from the tool calling agent. And next step is one, that is I don't want the agent to fall back to multiple steps if it fails in the first step. So this next step will just stop the agent from calling multiple steps after it fails from the first step. And then the agent is initialized. Now we can run the agent with the prompt that we want. So let's say what do we get if we multiply this big number with this number, right? So if we provide this and try to run it here, we can just do a python main.py, and this should call the llama 3.21 billion and ask it what tool to use for this query, and then it will try to pass the variables like this use number 34437 as x and 567 as y, and try to call a relevant tool in any of these two tools provided in the that is initialized in this tool calling agent tools toolkit. So as you can see, it has called the tool multiply with the arguments x as this number and y as this number, and the observation is 1936. So 1 is the last number, and you can see 3 and 7 should have 1 as the multiplication number. It might be wrong, it might be right, but at least it's able to call the particular tool with the right set of arguments. That is what is an agentic workflow or agentic pipeline. So in this case, it is able to take this prompt and able to decide which tool to call based on what the user has provided, and providing that particular context, and also able to pass the variables correctly and able to get the result. The output generation, that is a different thing, but it is able to process the request it is able to pass the request and correctly process it as well. Here we saw that it took a lot of time for the local LLM to run, because it is only so my laptop is only CPU, so the llama model will run using the CPU only, so it might be performance low. However, we can change a few things. We can now call a different model which is hosted on the cloud or some other provider. We can use Mistral. So if you go into mistral.ai, you will see try the API, and you can try a free version of the API. Well, you have to sign into the portal and then provide a phone number for the verification, and then you will be able to get access to the API. Then you can generate an API key using here. I have already generated. You will also set the expiry date to this, and then you will be good to go for the usage of this API on Mistral. And then it has a few models that you can use for free, which are Mistral small, and there are one more model which you can use it for free. So we just change this, and then we provide the API key for this LiteLLM model to get what we want from this, and that should be it. And we can now try calling this agent using Mistral as the LLM and not the local LLM, and this will now call the API. you saw that it did the same thing, but it was quite fast. It was around order of magnitude fast from what it was locally. So it is able to do everything that we able to do. And now let's try to add more tools and see how well that performs. So let's say we add a few more tools. I've added two more tools now. Scrap web page links, which will take in the URL and try to get all the links from that particular web page. And one more tool, scrap web page content, which will take in the URL and get us the response text from that URL. So we need to make a few changes here. We can do scrap web page links and scrap web page content, and there we need to change the prompt as well because this is not relevant to that. So let's say what are the links in the web page. I'll provide my personal blog, so let's say /blog. Maybe that is not the right thing because it will have a lot of URLs in that. Let's go minimal. So what are the links in the web page? HTTPS. And now if we try to run this, it will call the Mistral LLM, and using the context it is able to fetch all the links from the website, right? So you can see /blog, /projects, my GitHub repo, and RSS link, even the mail link. It is able to get all the context from what we have found so far. It is not actually like 100% accurate, but we are not testing the accuracy of LLM. We are testing how it can parse the URL from the given prompt and how it is able to call the given tool. Like it is able to select the right tool using the context given to it, and it is able to call the tools. So let's get a little more depth to this agent. So now let's do one thing. Let's say I have a SQLite DB called local.db, and it has a schema with the single table of users, and I have populated it with some dummy values. Select star from users, which will list out all the entries into this users table, which will have 5 entries. Which will have 5 entries into the database. And now let's try to fetch this using LLM. So first we need to define some tools. Let's say we want to provide the context for the schema, right? So first we'll try to create a function called getDBSchema, which will fetch all the tables in the SQLite database and also the columns for that. So first we'll create a SQLite 3 connect to the local DB. We'll import SQLite 3 from the standard library, and then try to connect to the database, which is a file-based database, so it should not be connection type. So select name from SQLite master, where type is table. So this is basically a query in SQLite which will list out all the tables which are user defined in the database. Then we try to fetch all the name of the rows. So row 0 will try to fetch the name of the row for each of the tables in that particular order. Then in the schema we'll try to create this sort of dictionary which will pass it one by one for each of the tables. So for each table we'll try to pass this pragma type table info. So let me show you that as well, what it will do. So pragma table info, we have users. So it will just list out what is the type of it, like a schema of schema, but in a very user friendly way. So user 0 is the first like column, the name, the type of that, the default values, and so on and so forth. Then this will give us that. Then we need to fetch all of the relevant information. 1 and 2, as you would see, are the name and type of that column. So we do this kind of formatting just for LLM to understand it better way. Then we close the connection and just return the schema which will be generated. As you can see, schema is a dictionary for each of the table that we are generating it using a nice formatted string. Then we define a tool which will convert the text into a SQL query. Now this will take in the natural language query and generate a SQL query. So here we need to not ourselves write the query, but take LLM the control of what it wants to generate. So convert the natural language query into a SQL compatible SQL query considering the DB schema that will be provided in the context. Argument is natural language query as you saw, and return type will return value will be the SQLite compatible SQL query. Now first we get the schema, that is the get DB schema that we just wrote, right? Because we don't want it to be passed from the LLM agent, then it will do it. We want to necessarily do it because every SQL query will need a schema of it. So we don't want LLM to call it. It might call, it might not call it. So we will forcefully call it here. And in this we'll provide a system prompt which will write the SQL compatible query for the following database schema. So we'll provide the database schema into the prompt and ensure that SQL matches the schema and parameters are passed properly. So just regarding the LLM, not to do any random stuff here. Your task is just to provide a query and not produce the result. So we just clearly mentioned that it has just to create the query and not execute it. So it creates that query. Then we define the model. Because this is an independent tool, we don't want LLM to take control of it. We want definitely to run this LLM as well. So we'll provide the model ID as Mistral. We can hard code it any way we want. Provide the API key, and then we call a code agent, not a tool calling agent, a code agent, which will take in the model, provide some tools. We don't want to provide tools. We want it to generate the SQL query code for us, and then run this with the system prompt and natural language query. Now you can generate this however you want, but this is like a very simple way to call an LLM to generate the code for you. Then we just return the response and then define one more tool which will be execute the query, which will take in the query generated from LLM and return the results. Execute an SQL query on SQLite database and return the results. So this will take an argument as a query and return a result of the query. It could be anything. First you need to connect with the database, right? And then open the database connection, then execute the query. Simple, right? We only want it to have a select, so we'll fetch all the results. If there is a, we want to commit, or we want to make changes, or we want to mutate the states, if there are any operations which are not just read or write operations, then we need to commit to the database. We won't be doing this in this example, but we can see this generic function tool to be used. Then if there are exceptions, we throw the exceptions and then close the connection and then combine the results however we want. And now here we need to add these two tools, convert text to SQL query and execute query. We don't want to provide the getDB schema because it will already be done with the convert text to SQL query. Okay, so ideally if we pass the prompt like what is the user's name with the ID as 2, we already know that, right? It is Bob, but let LLM take control of it. So let's say what is the user's name with the ID as 2, and let us try to run this and let's see what Mistral gives us in this context. It should be pretty quick, and you can see it has logged out a few things. Select name from users where ID is 2. It has successfully generated that SQL query, and indeed it has given us Bob as the name, which was correct. The output is little weird. It is not able to get out of that generation result, but it is able to do that thing which we expected it to do. So that is it, right? Like we are able to do a lot of things in this example here. That is, we passed in the natural language query, which was what is the user's name with the ID as 2, and it identified that he needs to call convert text to SQL query with the arguments the natural language query and select the name from users where ID is 2. Okay, it has already converted that, but you get the point. So it got ahead and created an exact query that we needed. Select name from users where id is equal to 2. Right? We probably don't need this intermediate step, which is convert text to SQL query. But if this was a very simple query, let's say the query was what is so let's say what are the users with whose name start with the letter M, right? So in this case it is a little complicated than that. So let's see what it gets us. So we know the result, it would be Megan and Michael with ID 4 and 5 respectively. And yeah, it is able to do that, right? 4 Megan, 5 Michael. So it is indeed able to perform that queries, right? You would see here that users whose names start with letter M, and now it has provided a natural language query as users name whose name start with the letter M. It is not able to write that query for us, so we need to explicitly provide what is the context, what is the schema, what are the columns, what are the data types of each of the columns, and then let it generate the query, which it rightly did, as select star from users where name like M percentage, which will be saying that the name should start with M, and whatever is after that we don't care about that. So M percentage is the correct way to query the table with the where the name starts with M. Okay, so yeah, that is it. That is how we did LLM with using SmolAgents. It is a very minimal library. You don't need to provide any complex graphs or anything, but it is just adding tools and combining the results, calling the tool calling agent whenever you have tools, and calling the LLM whenever you want a simple request. That's one cycle. So that is what SmolAgents are. It is a really simple, lightweight library. You can give it a star. It's really great to use. It even has a LLM agent course. You can head out into huggingface.com and you can see the agents course, which is quite extensive in terms of what you can use, the transformer models, LiteLLM that we use, the code agents, and other things that we can use out of the box. So yeah, give it a try and we will see how we can extend this in any other frameworks or any other ways or any other agentic routes that we can build using LLMs and tools. That is it from this video. Thank you for watching.